Okay, today lesson 19AA, and the reason why it's AA is because it's day number 2 of two-step equations. And yesterday we talked in full detail how to solve two-step equations. And today we're going to take that a step further and actually state the properties, and I mentioned that yesterday. We're going to state the properties used when solving, and then we're also going to check our solutions to make sure that what we get is correct. And one of the things we have been working on lately, as far as the language objective goes, is to write equations from word phrases. And the reason why you have nothing to write down in the why am I learning this is because since this is day 2 of the same lesson, it's the same why am I learning this. So let's get started. Yesterday, this was the very first problem that we talked about. And we showed it with some algebra tiles, and then I showed you by using math. And so we always want to deal with the adding or subtracting part first. The inverse operation to adding one is subtracting one, so we want to subtract 1 from both sides. And then remember the check, and we ran into this when I was answering questions in homework today. Make sure that those two things are opposites of each other, because if they're not, you're not doing the right thing. From there we have 3x equals 6. And now we do the inverse operation to multiplying by 3, which is dividing by 3. And we get a solution of x equals 2. And we've talked about all of these little things over and over and over again. And we talked about why you should add or subtract first as opposed to multiply or divide. And we talked about the rules for transforming equations. And all the properties that we use when we solve these types of equations are the addition property of equality, the subtraction property of equality, the multiplication property of equality, and the division property of equality. So here is number 1. And what we want to do is we're going to do the work the same way that we did yesterday, but we're going to do the work in this part, this area right here. Justification is which math property we're using, either the addition property or the subtraction property or a division property or multiplication property. And then over here, we're going to be checking to make sure that we got the right answer. So I'm going to demo number 1 and number 2. So everything that I write down, other than what I just wrote down right there, everything that I write down, you need to write down. Okay? So let's write down the problem inside the work section. To solve this problem, of course, the first thing we need to do is to add 5 to both sides. So let's write that down. From there, we added 5 to both sides. When we add a number to both sides, that's called the addition property of equality. Write that in there, please. Now, after we do these first two, I'm going to let you abbreviate a little bit. But when we get to number 3, actually, you know what? I'm going to show you right now. Here's how you could abbreviate that. ADD for addition. Property can be written like that of EQ. That's how you could abbreviate that. Okay? Addition, property of equality. Yours hopefully is neater than mine. It's hard for me to write that small with my finger. Okay, so now we're going to simplify that equation a little bit. We made our 0 there, and we now have 2x equals 24. And then to finish that, we divide both sides by 2. That is the division property of equality. Justification means you're listing the property that we're using. Here's how we could abbreviate division property of equality. div prop of EQ. Division property of equality. Now, from there, we finish solving our equation and we get x equals 12. So, we've solved it in the work column. We've listed the two properties that we used, and it's okay to abbreviate them. Now the only thing we have left to do is to check our answer and make sure that it's right. So here's what we do. So the first question is, how in the world are we going to do that? Well, I'm going to bring up something that we did, I believe it was the 3rd lesson this year. Everybody know what to do if I were to give you problems like this, yes or no? Yes. Those are easy, right? C is 5, so we substitute 5 in for C, and we find the answer. In number 2, B is 4, so we substitute 4 for B, and we find the answer, or we simplify. Number 3, A is 3, we substitute 3 in for A, and we solve or simplify. And the same thing in number 4. Well, that's really what you're doing when we check. So we're going to come back to this problem. So let's write the original problem down. And how we're checking is we're checking like this. We're going to check to see if 12, when we substitute it in for x, if it makes a true statement. So let's do that. Every time I replace a letter with numbers, I always use parentheses. So we're going to substitute 12 in right there. And here goes 12, right here. Boom. The question is, does that make a true statement? Does it? Sure. 2 times 12 is 24, and 24 minus 5 is 19. So that means I know x equals 12 has to be right. Now, before anybody panics and thinks that I'm going to give you 30 problems where you have to show your justification and your check, I'm only going to give you 4 problems where you have to do all of that. The rest of them, you can just solve them. And then after that, it'll probably just be 1 a day. But when I ask you to show justification and to check, this is what we're doing. Okay, this is what we're doing. All right, so let's now go to number 2. And I'm going to do this one with you. Hopefully I can go a little bit faster this time. Let's start by writing the problem in here. The work is just the work to solve the problem. So we subtract 1 from both sides. That's the inverse operation. That is the subtraction property of equality. You can go ahead and abbreviate like I've talked about. How are you going to abbreviate subtraction? Sub, exactly. So SUB, period, PROP, period, OF, and then EQ, period. From there, we've made our 0. So we have negative 8x equals 24. The inverse operation to multiplying is dividing, so we're going to divide both sides by negative 8. That is the division property of equality. You can abbreviate that. We solve our equation, and we get x equals negative 3. Okay? All right, so now we just need to check our answer to see if it makes a true statement. So we start with our original problem, or our original equation, negative 8x plus 1 equals 25, and we're going to substitute negative 3 in for x. And remember, anytime I replace a letter or a variable with a number, I always use parentheses. And here comes negative 3. Negative 8 times negative 3 is positive 24. So we have 24 plus 1. Is that equal to 25, yes or no? Yes. So that means that x equals negative 3 is the solution. Okay? Here's what I want you to do. I want everybody to try number 3, and then we're going to check that one with our shoulder partner. Go ahead and do all 3 parts for number 3. All right, I saw lots of good things that time. For the work, it's just the normal way of solving. To solve this one, we would either subtract 15 from both sides or add negative 15, however you want to look at that. So if you said add negative 15, that's the addition property. If you said subtract 15, that's the subtraction property. They both mean subtraction, so I just wrote subtraction right there. And then I made my 0 just as a double check, and so I have this. Now I have to multiply both sides by positive 3 to solve. That's the multiplication property, and I don't know why it says division property right there, but that should say, this should say multiplication property right there, okay? All right, and we get, for a solution, x equals negative 27, so I'm going to substitute that in for x right there. And now I need to check to make sure everything's okay. Right here, this part simplifies to negative 9. So I have 15 plus negative 9, and that is 6. So yes, that does make a true statement. All right, everybody try. Number 4, same idea. All right, I heard lots of good things again, and I like it when you guys disagree and you're trying to figure out who is correct and you're helping each other out. That's one of the things we should be doing when we shoulder partner. So in this one, let's go through this quickly. We need to add 4 to both sides the check is making sure that these two things are opposites. And if they're not, you're not doing the right thing. And they are, that is the addition property of equality since I added 4 to both sides. And then I have to multiply both sides by 5. That is the multiplication property of equality. And we get x equals 35. To check, I substitute 35 in for x. Right there is where 35 needs to go. And then I need to make sure that that makes a true statement. And it does. 7 minus 4 is 3. Okay, so here's what we're going to do on 5 through 8. 5 through 8, I want you to pay attention up here. And I want people to tell me which property we should be using. So you don't really need to write anything down for 5 through 8. In fact, 5 through 10. Because I think we've pretty much got it down. But before we do that, quickly, turn to your shoulder partner. What do we know about what we're doing so far? Go. All right, so I heard something about writing down the properties, and I also heard about checking answers, and that is basically what we've talked about. Okay, in this one, raise your hand if you could tell me which property I am using right now. It should be obvious. Equality. It's called equality because we're using it with equations. We're trying to make sure that things remain equal. Okay, and then I need to do this. Which property is that? Okay. Of what? Of equality. There we go. And then, of course, we should take that answer and check. And, of course, it does make a true statement. All right, which property am I using right in this one? What's the first property that I used?
Subtraction property of equality.
What property did I use second?
Division property of equality.
Okay, good. And when I plug those in, or plug 4 in, or substitute 4 in for x, it does make a true statement. All right, I think we get the idea here. So let me just zip through the rest of this. One thing I do want to show you is this, that all of this even works if we end up with a mixed number for an answer. For example, in this one, I need to add 7 to both sides and then divide both sides by -4. And look, even though we ended up with w equals -7 1/4, we can check it exactly the same way. -4 times -7 1/4, we would probably have to do that work off to the side. -4 over 1 times -29 over 4. And we can see that we end up with a positive 29 right there. So it even works whenever our answers don't come out even. In other words, we end up with mixed numbers or decimals or anything like that. All right, let's do our language objective. 8 more than 3 times the number y is the same as 29. Any idea on what our equation should look like for this? I'm not worried about solving it. All I'm worried about right now is writing it as an equation. Yes?
3 times y equals 29.
What about the 8 more than? What happened to that?
8 plus 3 times y equals 29.
All right, so here's what was just said. 8 plus 3 times y, which is 3y, equals 29. I have something to tell you. That is not correct. Right? One of the reasons why I've been giving you those problems in the homework, all those flip terms, is this one of those flip terms?
Yep.
Yes, it is. What should it really be? What should it really be? Yes?
3y plus 8 equals 29.
There you go. Okay? That's what it really should be. And remember all those 5 flip terms. More than, added to, less than, fewer than, and subtracted from mean to flip. And I think at this point we all kind of know how to solve that. Everybody take a look at number 12. Write from words to math. What would that equation look like? What does this look like? Excellent. You remembered that quotient means division, or x over 2, and you remembered that less than means to flip the order. So why in the world are we concerned about this sort of thing right here? Well, the reason is because coming up very shortly will be a section probably that will take 3 or 4 days where we deal with a whole bunch of word problems where we have to take and turn them into equations like this and then solve them. And I know I'm very confident that if I gave everybody that equation to solve, you would be able to do it. But the key is taking words, turning it into that so that we would know how to solve. All right, we are finished for today.